All right, it's going on 106 when we are done. So we're going to look at inverse trig functions. We've talked about inverses for other functions. You have known about inverses for a while. I know you did them in Algebra 2. You did a little bit of them in Algebra 1. For a function, so this says a function has an inverse if and only if it is a one-to-one function. Okay? Being a one-to-one function, remember, means that you pass not only the vertical line test, but you have to pass the horizontal line test. Okay, that's what makes it a one-to-one function. That means the function and its inverse are both functions, right? And that's what that next part says. All right, so if you look over at the sine function on the board over here, is that a one-to-one function? No. It's a function. It passes the vertical line test, but it absolutely does not pass the horizontal line test. Okay? So, but it goes on to say, however, if the domain is restricted to a certain interval, the sine, cosine, and tangent functions have inverse functions. So we have to restrict the domain so that we can actually have an inverse. And that restriction is what starts to make some things confusing until you wrap your mind around it. Once you can, and you have to think about these graphs and this x and y axis, and then you have to also be able to think about the unit circle and its quadrants. And those are two completely different things, but you have to be able to think about them together. Okay? Now, let's talk about some notation here. So it says the inverse of the sine function is the arcsine function. So you write that as arcsine. This is how you abbreviate it. So for sine, we get arcsine, which is the same as sine inverse or inverse sine. Okay? They mean the exact same thing, just two different ways to talk about it, two different ways to notate it. So you don't do anything any different. And we've been taking the inverse to get angle measures for a long time. So then for cosine, you get arc cosine. So it's abbreviated like this, or it's cosine inverse or inverse cosine. Then tangent gives you arc tangent or tangent inverse. Okay, so you need to be able to see both, understand both, know that they're the same thing, and there's just different ways to say it. Okay? All right, so we're going to start with the arcsine function. So to do that, we are going to start by graphing a little sine function from negative 2 pi to 2 pi. So here's one period, and then here's the period going the other way. That bothers me. Okay, good enough. And that's basically what we did with the fettuccine, right? From negative 2 pi to 2 pi. So we have, this is an x and y axis, this is a function, this is a graph, but remember, we got it from unrolling our unit circle, right? So we need to also be able to think about how the unit circle applies to this, meaning that, okay, this is, I know that this is 0, this is 2 pi, right? This is pi, so what's this? Pi halves, and this is 3 pi halves. Okay, so thinking about the unit circle, the first quadrant of the unit circle goes from 0 to pi halves, right? So these are all our first quadrant values. From pi halves to pi, what quadrant of the unit circle are we in? Second. And so this is all of our sine values in the second quadrant. And sine is positive in the first and second quadrant. That's why we have all these positive values here. From pi to 3 pi halves on the unit circle, we are in quadrant 3, and sine is negative there. That's why we have these negative values. From 3 pi halves to 2 pi on the unit circle, we're in quadrant 4, and that's why our sine values are negative. Does that make sense? So do you see how you can relate the unit circle quadrants to this? Like on this particular function, the quadrants, we don't really care about the quadrants that way. We think more about the quadrants in the unit circle. Okay. Now I took the cosine graph right here and I flipped it. Well, it's not, I would have to reflect it where you can't see it, but basically reflected it in a way so that you could see what it would look like if we took the inverse. And that clearly it's not a function, right? And this is why we have to restrict the domain. So I just have to have part of it. And so I need part of it so that when I go backwards, I can go ahead and take care of all the values, because this just keeps repeating, right? Even this set of values and this set of the values, they're the exact same y values, aren't they? They're just different x values. So I don't need all of them. I only really need to get from here to here, and this is all of the positive sine values that exist. And then all of the negative sine values that exist are right here. This is pi halves. What is this x value? Negative pi halves. Okay. on the unit circle, if I go to negative pi halves, I could also get there by doing which angle? Which positive angle? Close. 3 pi halves, right? So on the unit circle, whether I go a positive 3 pi halves or a negative pi halves, I end up in the same spot. Make sense? On this graph, this is negative pi halves, this is 3 pi halves. Clearly, not the same thing, right? So although they are coterminal angles, they're not the same angle, all right? We're going to restrict our domain of the sine function where I can only go from negative pi halves to pi halves. Like, that is it. Those are the only angles we're going to get to talk about, period, end of story, when we're doing inverses, all right? And so that means that this is the first quadrant of the unit circle. What quadrant of the unit circle is this? 4th. And in the first quadrant of the unit circle, sine is positive. In the 4th quadrant, it's negative. Okay? And that gives us all, because then we also have positive and negative over here, but they're the same values as these are. We only need these 2 quadrants. That's it. So right here, we're going to graph that. We're going to graph that sine function just from negative pi halves to pi halves. So at negative pi halves, what is the sine value? Negative 1. At pi halves, we're at 1. And then at 0, we're at 0. And it's this piece right here, so it looks like this. And the way it curves is important there. So for this little piece that I just graphed, what is the domain? Negative pi halves to pi halves. Do I include the pi halves? Yes, I do. What is the range? Negative 1 to 1. Yes. Okay, so now we're going to take the inverse. And when we take the inverse algebraically, we just exchange x and y, right? Which means the axis gets changed, the domain and range gets exchanged, everything just flip-flops. So that means my new domain is this range. We go from negative 1 to 1. And then range is that domain, so it's negative pi halves to pi halves. So now your y-axis has the pi values on it, not the x-axis, because they switched. Okay, everybody good so far? So then we also have to think backwards. And if you don't know your trig values going forwards, this is going to be impossible for you. Because you got to know them well enough going forwards that you can do it backwards. So then you have to ask yourself, when the sine value is negative 1, what is the angle measure? Negative pi halves, right? When the sine value is 1, the angle measure is pi halves. And then 0 is still 0. But remember, this is a reflection, so it's not the exact same graph. It actually looks like this. But that's right. Why I can never hit it the first time. There we go. It curves in the opposite directions because they switched places. Okay? So I can take the sine, cosine, or tangent of any angle. Okay? Any infinite angle anywhere. And I only get a set number of values out, right? There's only a few things that you can have answers for sine. But when I take the sine inverse, I don't have an infinite number of angles that are my answer. I can only give an answer that's between negative pi halves and pi halves. That is it. Okay? Does that make sense to you? So even though I could get some other values in the other quadrants, these are the only acceptable answers because of the function. Okay? We good? All right, so let's look at cosine. So for cosine, we're going to start off by doing the same thing. We're going to graph from negative 2 pi to 2 pi. So it looks like this, like that. Better, but you get the idea. All right, so now, so out here, this is 2 pi. This is halfway, so this is pi. This is pi halves. This is 3 pi halves. This is the first quadrant of the unit circle from 0 to pi halves. This is the 4th quadrant. Well, if I use the first and the 4th quadrant like I did here, that gives me all the positive values, and we don't look at the negative values at all. That's a problem. This is just the same thing over again, right? So I don't need all this. I want to start here, and if I go use this part and go to here, then that gets me all of the positive ones and all of the negative ones before I repeat the values itself. Mm-hmm. Yes. because that's a reflection. When you take the inverse, it's a reflection on the line y equals x. So they have to be different. Because whatever this is right here, they're not the same point. Let's say that this is like 1/2, negative 1/2, negative 1. This becomes negative 1, negative 1/2. The x and the y values switch places. So the curve is opposite. They're not the same. Y is x and x is y. All right. So for cosine here, we are using which two quadrants of the unit circle? First and second, because cosine's positive here, negative here. So instead of going from negative pi halves to pi halves, we are going from 0 to pi. Okay? So I'm going to graph just that part from 0 to pi. So I'm going to start here at 0, 1. When the angle is pi, the cosine of pi is negative 1, right? And then pi halves gives me a 0. So the curve looks like this. So our domain, we go from 0 to pi, and I include them both. What is the range? Negative 1 to 1. So then when I do the inverse, they switch places. This domain, negative 1 to 1. My inputs can only be between negative 1 and 1, right? Just like my outputs for this, I can't get anything bigger or smaller than that. The range goes from 0 to pi. Okay, so when the cosine value is negative 1, what is the angle measure? Pi. When the cosine value is 0, what is the angle measure? Pi halves. And when the cosine value is 1, the angle measure is 0. So that means that this is what that curve looks like. Because again, it was reflected in the line y equals x. So notice for cosine, when you take the arc cosine, you're never going to give a negative angle measure. That doesn't make any sense. For sine or arc sine, you have to because you're going from negative pi halves to pi halves. Okay, we good? All right, let's look at tangent. So for tangent, this is the parent function part that we've been drawing, right? So basically, we'll just finish up this. We're not going to go all the way to 2 pi, but draw a couple of these in here. Okay, so there's some of the tangent function, right? Again, this is a function, not a one-to-one function, so I have to restrict it. Well, if I restrict, so like this right here gets me my, because we know from here to here is pi. So this is pi halves, which means this is the first quadrant of the unit circle. That gets me all of the positive ones. So I can just finish this up, and this would get me all the positive values, all of the negative values. And so for this one, we're using quadrants 1 and 4, just like we did for sine. So for cosine, we have to use 1 and 2, but for sine and tangent, we're using 1 and 4. Yes? Well, we do, because we're still going from negative pi halves to pi halves. It just, instead of skipping over this and doing this one, it just makes more sense to continue to use that. All right, so for this one, we are going to graph this. So from negative pi halves, so at negative pi halves, I do have an asymptote. And at pi halves, I have an asymptote. Got 0, 0. Pi fourths is 1. Negative pi fourths is negative 1. And then I can graph this in. So my domain, once again, goes from negative pi halves to pi halves. Do I include them this time? No, I do not, because they are asymptotes. What is my range? Good, negative infinity to infinity. So then when I take the inverse, those are going to switch. Domain is negative infinity to infinity. Range, oh, I said no, and then I put a box. Why'd y'all let me do that? Sorry. I said no, and then I still put the little bracket there, probably while I was explaining not to put a bracket. Duh. Sorry, parentheses there. That makes more sense, right? That's why we're not including them, because they're asymptotes. And then this is negative pi halves, 2 pi halves. So, when the tangent value is undefined, what is the angle measure? Pi halves and what? Okay, I know what you meant, but pi halves and what? Negative pi halves. When the tangent value is -1, what is the angle measure? Negative pi fourths. When the tangent value is 0, the angle is 0. When the tangent value is 1, the angle measure is pi fourths. Okay, so this right here is your inverse. There's that reflection. Okay. Everybody okay so far? I'm going to show you how we're going to apply this and why this matters here in just a minute. Okay. All right, so flip this over. All right, so the sine inverse function looks like this, right? And the values are from the first and fourth quadrant, the y values, your outputs. And not only is it from the first and fourth quadrants, but it goes from negative pi halves to pi halves. 3 pi halves is a different angle. Yes, it gets me to the same spot, but that's not in my range, okay? And so then cosine, the cosine inverse graph looks like this. And we are using first and second quadrant from the unit circle. So this is representing unit circle stuff. This is representing the function itself. Two completely different animals there. And then tangent inverse looks like this, right? And we are again using first and fourth quadrant angles. All right, so we're doing things the opposite we have been doing. I've been asking you what is the sine, cosine, or tangent of a specific angle. Now I'm going to give you that value and you have to give me the angle. So the arc sine of 1, when the sine value is 1, what is the angle measure? Pi halves. And remember, actually picturing the sine graph in your mind. So like, here's the sine graph, right? So you know that goes from 0 to 2 pi. Well, here's when sine is 1. That right there, you're at pi halves. I mean, you can get it from there too, whatever makes the most sense to you. All right, so then the sine inverse of the square root of 3 over 2. Hand trick still works. You make the sine value square root of 3 over 2, and then ask yourself, what is that angle? Pi thirds. There you go. What is the arc sine of -2? When you're thinking about this, that's the angle. We need this is the actual value. So what angle gives me a sine of -2, sine value of -2? Can't go over 1 or can't go below -1. Remember your inputs for this? So for your arc sine here, your domain, your inputs can only be between -1 and 1. So if they don't fit in that, it doesn't exist. So it's D and E, does not exist. All right, so cosine inverse of the square root of 2 over 2. Negative square root of 2 over 2, I'm sorry. So we know it's going to be a pi fourths angle, right? But it's not pi fourths because this is negative square root of 2 over 2. For cosine, what two quadrants am I using? 1 and 2. So the first one clearly is all the positive ones. My negative ones come from the second quadrant. So what's your second quadrant pi fourths angle? 3 pi fourths. Now, the cosine of 5 pi fourths is also negative square root of 2 over 2, but that's an unacceptable answer because I'm only allowed to go from 0 to pi with my answers. Okay? You can only use the first and second quadrant. All right, what's the cosine inverse of 3? D and E doesn't exist. What is the arc cosine of -1? Pi. -1 is pi. All right, so we're going to pause on that for just a second, and I want you to write this down, and this is something that might take us a minute to process here. The sine of 7 pi sixths. Okay, tell me, what is the sine of 7 pi sixths? -1/2, right? So it's -1/2. Do we all agree with that? Okay, so here's something I need you to understand, is that the sine inverse of -1/2 is not 7 pi sixths. Okay? My input for the sine function, -infinity to infinity, I can put in, 5,872 pi over 3,876. Like that's an acceptable input. My outputs can only be, the positive or -1/2 square root of 3 over 2, those sorts of things. However, when I do the inverse, my inputs can only go from -1 to 1, and my outputs can only go from -pi/2 to pi/2. Period. End of story. Okay? There's an infinite number of angles that will give me a value of -1/2, but there's only one that I'm allowed to put when I do the inverse. So the sine inverse, all of what? It's all limited, yes, but not all to the same quadrants. That's what all that means. So what do you think the only correct answer for this is? But sine of pi 6 is a positive number because we're in the first quadrant. I am only allowed to go from -pi/2 to pi/2. That's it. 11 pi 6 does not fit between -pi/2 and pi/2. -pi 6. -pi 6, which is a coterminal angle with 11 pi 6. But the value has to fit between -pi/2 and pi/2. Period. End of story. Okay? We good with that? Okay, so you have to, yes, there's other angles, but you have to know what your limitations are. From here, I only get to go from 0 to pi. On here, I only get to go from -pi/2 to pi/2. That is it. Those are the only acceptable answers. And that's why I think this quiz is important for you, because you're going to want to say some things that maybe is not even a choice, or you're going to get it wrong, and I think you might need to do it a couple times to kind of wrap your mind around it. Okay? We good? We okay so far? It's just trying to get your mind right. Once you figure out how it works, it's really not that bad, but it's a little weird at first, I know. What do you mean? For everything I just said on the front page. Okay. Yeah, okay. Well, then you can come to math time. All right, arctangent of the square root of 3 over 3. All right, so if I'm going to get a tangent value with 2 3's in it, what's the denominator of the angle? 6. So I know it's a pi 6th angle. This is a positive tangent value, which means it has to come from the first quadrant, so it's pi 6. If it was negative square root of 3 over 3, my answer would be negative pi 6. Okay? Arctangent of -1. Right. But it has to be the fourth because it's negative. Exactly. So what gives you what angle gives you a tangent value of 1? Or pi 4, so then it has to be negative pi 4. Good. Which again, if I take the tangent of 7 pi 4ths, I get -1. But that's not what this is asking, okay? Because we have to limit it between those two things, okay? All right, tangent inverse of the square root of 3. Pi 3rds. See, that's all it takes. It takes that little light bulb to come on, then it'll start. Yeah. Yes, exactly. Okay. All right, we good? This takes a little soaking, okay? We're going to let it soak in our brains. All right, let's look at number 10. A ship left port A and sailed 60 miles due east to port B. From port B, the ship sailed 120 miles northwest and stopped. And I left off a part again. Should say directly north of port A. Otherwise, this doesn't work out, and I can't believe I left it off again. All right, so I'm leaving port A. I'm going to sail 60 miles due east to port B. So this is 60 miles. Okay. Then the ship sailed 120 miles northwest and stopped directly north of port A. Exactly, and that's why that directly north is important. This is 120 miles. Then it says, find the bearing from port B to the current location of the ship. So the bearing that I'm looking for is this right here, okay? Which I can't directly find, but I can find this angle, and then I'd be fine, right? What is the simplest way to set something up to get that angle? That's not the simplest way. Nah, do not need to do all of that. You don't need to do that either. You don't need to do the law of cosines or the sines or the Pythagorean theorem. This is a right triangle, but I said the simplest way. This is a right triangle. You have two sides and you're looking for an angle. Can you just use SOHCAHTOA? Yeah, you can just use SOHCAHTOA. You don't have to, it's no side angle side, no law of sines or cosines. That angle, you have adjacent and hypotenuse. It is a very simple, very basic cosine problem. So, cosine theta equals the adjacent, which is 60, over the hypotenuse, which is 120. I need theta. So theta is the cosine inverse of what's 60 divided by 120? 1/2. All right, so what is the cosine inverse of 1/2? It's pi thirds. Cosine is 1/2. It is pi thirds. Now, we're talking bearings, so really I need this in degrees. What is that in degrees? 60. So this is 60 degrees. So the bearing is, well, almost. So that I can say bearing is not about, no. What do I don't just write 30 degrees. So what do I write first? No. You always go north or south first. It is north, 30 degrees, where? West. There you go. Never eat soggy waffles. Okay, let's look at number 11. The angle of elevation from a football on a football field to the crossbar and a goalpost depends on the distance from the base of the goalpost. Right theta is a function of d, which means that it has to be theta equals something with this variable in it. So again, I look at this and think of the simplest way to, if you have a right triangle, you do not need to do law of sines and cosines. This is opposite and adjacent, so that is which function? Tangent. So the tangent of theta is equal to the adjacent, which is d over the, the opposite. Sorry, I totally did that wrong. Let me back that up. Opposite, which is 10, over the adjacent, which is the distance. So in order to get theta, what do I need to do? How do I get tangent inverse? So theta is equal to the tangent inverse of 10 over d. And that's all, it says theta as a function of d. That's what I've got. I've got two variables, it's fine. Goes on to say, using your graphing calculator, which by the way, doesn't have to be a graphing calculator, find theta when d is 75 feet. So then you can substitute 75 in, and then you have an equation where you're not just punching buttons to get the number for b. You have to actually set up an equation. That is important. That functional thinking is important. Well, I didn't worry about you getting your calculators right now because I know you can type the buttons in. On the assignment, you have to actually finish the questions, but we're going to move on for this one. All right, look at number 12. Two cables are secured from the top of a 50-foot tall utility pole. So this is 50-foot tall. The lengths of the cables are C1 and C2. I'm going to write theta as a function of C1 and C2. So again, I'm going to get theta equals, and I'm going to have two variables on the right-hand side. Once again, I have a right triangle, okay? So since I have this right triangle and I have this length and then eventually we'll have these, I have two sides, I can find an angle. This angle is not an angle of a right triangle, but I don't need to be weird about that either because I would need more information that would make it way more complicated to actually find this angle directly. Instead, can I find this angle here? Yeah, and can I find this one? Yes. And so if I call this one alpha and this one beta, then the angle I actually want, which is theta, is going to be alpha minus beta, which I can't write over there because it doesn't say just write an equation for theta. It says in terms of C1 and C2. So now I've got to make those equations. So let's do alpha, this big one, right? This is the adjacent and the hypotenuse. So which trig function is that? Cosine. So this is the cosine of alpha is equal to 50 over C1. I need to solve for for alpha in order to be able to plug it in my little equation over there. So that means that alpha is equal to the cosine inverse of 50 over C1. Then I'm going to need to find beta, so I can use cosine again, and this time cosine of beta is equal to the adjacent over the hypotenuse, which is C2. So beta is equal to the cosine inverse of 50 over C2. So now I have alpha and beta that I can substitute into here. And alpha and beta are in terms of C1 and C2, so I'm good. So theta equals alpha, which is cosine inverse of 50 over C1, minus beta, which is cosine inverse of 50 over C2. And that's the equation I can use. So then they give me the lengths of 120 and 65, and then they could change the lengths. We could, that's where you can kind of play around with what if I need it to be this length or that length, and you have an equation and not you just punching buttons to get an answer. Okay, we good? What questions do we have? All right, go ahead and